Good day, folks. This is the lesson for teaching you guys the measurement of file size or measuring file size. We'll start with a pre-done homework of mine, which states the smallest unit of memory is bit, starting from the bottom down, bit being the smallest unit. Then comes the byte, or we can also focus in here, bit, byte, small b for the bit, and capital B for the byte. Okay. Then comes kilobyte, megabyte, and gigabyte. So the jump from bit to byte has a difference of 8, also been mentioned in here. Okay. The jump from byte to kilobyte, kilobyte to megabyte, megabyte to gigabyte, these jumps, even here, all these jumps are of 1024 for each jump. You have to pay 1024 for each jump from byte to kilo, then kilo to mega, then mega to gigabyte. Okay, so one of the most confusing things for students to decide when to multiply and when to divide, and with what to multiply and with what to divide. Okay, if you are given with the bits to go into the byte, okay, even if I don't explain, just let me read what I have already prepared. When one thing gets bigger, in this case, when unit gets bigger, the value gets smaller. Okay, for the sake of instance, I also have an example down here. 1,000 meter are equal to 1 kilometer. 1,000 kilometer is equal to 1 kilometer. If you look at the left hand side, 1,000 meter, 1,000 is the bigger value, unit is smaller. When we convert it into kilometers, we obviously do something which is the division process. We divide it by 1,000 because there is 1,000 in 1 kilometer, 1,000 meter in 1,000 kilometer. So that gives us 1 kilometer. I have said balance is maintained in the trade-off. Trade-off means you have eaten up 1,000 and have produced 1 kilometer. How the balance has been maintained? If you notice that with the 1,000, the unit is small, which is meter. Okay, and when kilometer, uh, the value is small, but the unit is bigger. So in any of the case, when there is a bigger value, the smaller unit, on the right hand side, smaller value but the bigger unit, the balance is always maintained from on the both left and right hand side. As an example or a quick example, if you are given with 25 bits, then I ask how many bytes in it. Okay, how many bytes? So the first question is whether to divide or whether to multiply. So what we want is the smaller unit to get bigger. So as a trade-off, the bigger value must get smaller. So there won't be 25 with the bytes, but a smaller value, because we have a bigger unit here, and a bigger value here. So value must trade off with the unit. So to lessen the value, to decrease the value, we have a division process only, because it is always the game of multiplication or division. No minus sign in here or no addition in here. Okay, so first of all, we decided that we need to divide. Then divide with what? Okay, divide with what? That is the thing that I was trying to tell you guys, that each jump on this side has a particular value, that from bit to byte or byte to bit there is unit of 8, and then after byte to kilobyte there is a unit of 1024. So we are transferring we are interested in bit to byte or byte to bit. From in this particular example, we're gonna go from bits to byte. So division is the thing we need to do, but with what we need to divide 25 is the second thing is 8. So 25 divided by 8 is equal to some bytes. 8 fours are 24, so 4 point something, 4 point something, or I can produce something with underscore 4 point something. I guess it will be 0 1, I guess, or I don't know, whatever it is, 4 point something bytes. So the unit has gotten bigger, which is byte, but the value has lessened from or decreased from 25 to 4. So always think in terms of what to do, whether to divide or whether to multiply. In that case, you can think of it as a ladder, that if you need to jump up, then you need to have some energy or you need to lose some energy. Obviously, when you are climbing up, you are losing energy. Your breath or the rate of breath is increasing. That means the energy of the body is being consumed. So division is the process which engulfs, which eatens up, which cuts down the already given value. In this case, 25 has been cut down to 4 point something. So division is that process. You need to decide whether you need to divide or multiply. Okay, that is why I have here in the form of graphics an analogy of the ladder, whether to come down or whether to go up. Coming from top to bottom requires none of the energy. The gravity helps you with that. So you will have a gain of energy. Or in other words, the unit from the terabyte, the bigger unit, which is terabyte, is going down. So value must inflate to maintain the balance. Again, when one thing gets smaller, the other gets bigger. The other get bigger, the one thing gets smaller. So the one thing and the other things are here, the value with the unit, value with the unit. So you just need to look at the units and the value. Okay. So whether it is this way or it is this way. All right, so I'm gonna erase everything up. There I should keep writing 8. Okay, so I have an example from the past papers. It says, is the summer 19 paper 1 variant 2 question 4, Marley needs to store 10 8-bit color images. First of all, there's the unit 10. Okay, we need to keep the reminder of it. Then 8-bit color images, fine. In a file for his project, each image is 500 pixels wide, means 500 pixels wide and 300 pixels taller. Okay, I can write px, fine. Calculate the total file size in megabytes, fine. So the first step is to has the resolution. Let us change the ink to red. Okay, and the size, fine. We have the resolution is the first step we need to perform, and there I'll take blue. Okay, 3, fine, yeah. So resolution is always finding the area, width multiplied by height will give us 5 3s are 15 and zeros remaining as it is. Okay, so the unit must be written as px, or to make you guys remember it, write px with it. Okay, fine. So this is the area or the pixels in a square or a rectangular of 500 into 300, fine. Then we need to convert pixels into bits. For that, we're going to look at how many bits are being used by each pixels. Marley also needs to store 10 is a separate thing, 8-bit color images. That means each pixels of the images using, always remember the number of bits given are for single pixel only. Okay, color images. So for that instance, we need to convert from px to bits, or I can write pixel to bits. All right, for that case, we're gonna do what? If single pixel is taking 8 bits, then how many 150,000 pixels gonna take? Obviously multiply by 8. It is just like if one person is consuming 2 breads a day, if one person is consuming, one person 2 breads a day, how many 3 persons obviously 2 multiplied by 3. Okay, total. Okay, so same we have done in here. 8 bit per pixel. How many for 1500,000? 150,000 pixels. 150 into 8 is equal to, to make sure there are 5 zeros. Yeah, there are 5 zeros. 1200,000. Fine. The unit, never forget the unit. This is the proper way to do this kind of questions. So you never get distracted. Now we need to convert bit to byte because the final unit is for the byte. We know after bit comes the byte, so we'll convert a part of bits to byte. Then we'll look for the mega part. Okay. So third step is bits to bytes, and that is there are 8 bits in a byte. 8 is the thing. Okay, so now we need to decide whether do we need to multiply or divide. We are gonna go from smaller unit to a bigger unit, which is byte. So if unit gets bigger, the value gets smaller. Value is smaller down by, or value is decreased down or lessened down by division. So we need to divide, and 8 was the thing which we separated out. So 1,200,000 divided by 8 will give us something of bytes. 1200,000 divided by 8, 150,000. No, sorry, blue ink. Oh, I'm gonna start it from here. 150,000, or yeah, 150,000. Yeah, we got the same thing back. If you look at here, 150 again, 150. How? Because 8 bits are actually the 1 byte. So 8 bits are actually the 1 byte. The process where we converted px to bit, or px to, we could have directly converted it from px to byte, because one way or the other, here we did what? We multiplied with 8, and then on this step we divided it by 8. What divided it by? Again, I'm gonna tell you guys in a proper way. We had 150,000 px. Okay, so from px to bit we need to multiply it by 8. Then it could had given us small bit, a small b or bits. Then from on the third step, from bits to byte, we need to divide it a whole by 8 to convert bits into byte. So that could simply mean 8 by 8, which is 1. So what remained is 150,000. Okay, because 8 bits are 1 byte. Fine. So byte. Okay, now what remained is the mega part. Again, we're gonna go from a smaller unit b to mega. Byte is same. Fine, we need to look at only byte to mega. So we have a jump of byte to kilo first, then kilo to mega. Each jump takes 1024 units of energy to grow from bottom to top, and there are 2 jumps. So we'll have to divide, because smaller unit the bigger unit, so the value must get smaller to compensate for the bigger unit. So from bits to byte, the last step is bytes to sorry, got much longer. Bytes to whatever unit required, so 150,000. Okay, we forgot one more thing. Not forgot, I remember it. This size in bytes was for one image, because we only did 500 into 300, then into 8 bits, then divided by 8 to get into the bytes. So what we did was actually for one image only. But here he says we have 10 images, just like if one pixel takes 8 bits, then how much 150 pixel 150,000 pixels takes, so we multiplied it. So we multiply this with the 150,000 with the 10, so that must give us, so I'll remove the um, thousand separator, one more zero. Okay, or in other words, I'm gonna, sorry, uh, write it down properly. 150,000 into 10. Okay, that gives us 1 or 1500,000, just a zero added. Okay, for 10 of the similar images. Now we need to divide 1 or 1500,000 with 1024, one jump, then the second jump. Dividing multiple times by the same thing is just like divide it in multiplication with that thing. Just like 1024 into 1004 into division means like something divided by 1024 divided by 1024 can be written as something divided by 1024 into 1024. Same effect. Okay, same thing. So this must be your answer in megabyte. But for you guys, of these 3 marks, 1 mark is for the final answer, and 2 marks are for the working. So you could add an approximate answer. Do produce it in here for the examiner so that he knows you know the process. I see it as, I've also taught you guys, if you cannot do it manually, the division with 1024 into 1024, get the answer of the multiplication first, then divide 1500,000 with that multiplication. Or we can simply look at kilo, as in physics or maths, like the units of, like in thousands. Mhm. Sorry, we're gonna write it again. 1500,000, and looking kilo as a unit of thousand. Okay, so 1 2 1 2 1 2, 3 zeros cut off with those, zeros cut. The 15 by 10, definitely you're going to approximate it to 10 ones are 10, and then 10 1.5, almost 1.5. Or you could write 1.4 again dot, sorry, dot ahead of it, 1.4 something. So I already know the answer. 1.43 it is, I guess. I haven't calculated it, but I've look at its marking scheme. 1.43 is the final answer. By this method you're gonna get 1.5. Okay, so an exam you could have written, if you could not do such a little much of calculation, you could have written either 1.5 or 1.4. Fine, not even 3, 1.4, because definitely we have lessened 1024 to 1000, so it must, or it might never gonna be 1.5 exactly. So by a method of trial and error, or by method of guess, you could have produced 1.4. In marking scheme it is 1.43 actually. Okay, so now I'm gonna move to the second question, and we'll try to do it as fast as possible. I'm gonna do what? Change the ink. Okay. Explain the term pixel, the part A. The pixel is picture element. It is actually from the book of Horror Education on Computer Science for O levels. Picture element. First keyword, then composed of three colors. Obviously, we'll write it in the form of a sentence, a proper sentence. I'm just writing the keywords composed of three colors, or COLORS, whatever you like. RGB in bracket. Okay, so 1 mark. Fine, we have produced the answer of 2 marks for it. Color depth. Color depth is the number of bits used to store color depth. Each, sorry, pixel. Obviously, we write it in full spelling. Each pixel. Then calculate how much of these images could be stored on a 32 GB memory stick. So I see it as 32 GB of cake. A cake of 32 GB. How many cuts? How many cuts of this much size of an image could be made on 32 GB. So we need to do what is to calculate the size of each image. So I'm now gonna look at main question. A bitmap image has the following resolution. Okay, 1140 into 1080 px. The image uses color depth of 24 bits. So again, following those steps, first of all, resolution. Okay, I'm gonna short it down. Res, red as. Okay. Resolution 80. That gives us 1231 200 px. Oh, again, I'm gonna write the unit so that you never forget to write the unit in px. Okay. Then px to bits. We had the process of px to bits. That follows the number of px multiplied with the number of bits given in the question for each pixel. So 24 must be multiplied with 1231 200. And we know the third step is from bits to byte. We know the third step is from bits to bytes. So instead, I'm gonna perform the step third for now before the step two. So how many bits do we have? 24 bits. 24 bits divided by, obviously we had to perform to divide it by 8 to convert from bits to byte because the jump is of 8 units. So it gives us 3. Okay. Now instead of multiplying 24 bits in part or in step number 2, we're going to just multiply with the 3 to directly get the answer into bytes. Okay, so I have performed the step third before step 2 to get an easy working that we could do manually without calculator. Now 1 2 3 1 200 multiply by 3 and it will give us in bytes. Multiply by 3, 3693 3600 bytes directly. Otherwise we could have done it proper way, which was 1 2, this is what I'm following, 1 2 3 1 200, multiply by 24 for the step 2. Then in step 3, the same, the answer of the same, or much better, is equal to question mark in bits, something in bits, then question mark divided by 8 to get the answer in question mark double question mark bytes. Okay, so the same thing is being done in here. That what I had done, I had divided 24 from the step 2. From here I divided it by 8 to get 3, then multiplied 3 directly here to get the answer at the step 2. Okay, I have applied some shortcuts. I hope you understand it. Do rewind the video again and again if you could not. Okay, yeah, fine. Right, so bits to byte 24, we have done it, bytes, fine. Now we need to do what? We need to do, yes, we already knew, we need to divide 32 GB by the size of a single image. So in order to know how many cuts on 32 GB by that image size, but we have got the image size in bytes, which is this one. So we need to convert the image, single image, to gigabyte. That would be too much of a division. So instead of bringing byte to the gigabyte, bringing byte up to gigabyte, when we'll do what? We'll do 32 GB, sorry, 32 GB to bytes. Okay, so 32 GB to bytes, we have the steps of G to mega, then mega to kilo, then what? Byte. In any way, it gonna go complex. Or we're gonna do both of the calculation from byte to GB and from GB to byte. Any way around, you must be confident in doing both of them. So we have these many of pi. Remember why we are doing this. We have 3693600 bytes, and on the other hand we have 32 GB. So both of the units must be same in order to divide 32 by the image size. So we just want to make the unit same, either both in GB or both in bytes. So we're gonna do both way around. Okay, so here we're gonna do byte to GB, and on this side we're gonna do GB to byte. Fine. I'm gonna change the ends to, it is already yellow. Fine. For this hand side we'll go with the orange one. 3693600, 3693600 bytes we have. I'm gonna underline instead of writing it with the red now. So from smaller unit to bigger unit, we'll have to pay something, and in order to pay something, we get divided by, we get shortened by the value on the left hand side with the unit. So 3693600 divided by how many jumps we have in between kilo and mega, then comes the GB. So we jump from byte to kilo, first jump, then kilo to mega, second jump, then mega to GB, third jump. So each jump has the or takes 1024 units of energy. 1024 into 102, from analogy, the energy this way. Or we have 32 GB on the other hand side. The value is 32 GB. The unit is already very big. From gigabyte to byte, it will be a free fall. We'll have a gain of energy, and multiplication is the operator that gives us the gain of energy. 32, same steps, same number of jumps. 32 multiply by 1024, multiply by 1024, then again 1024. Okay, so in both of the cases we'll have, well, here we have gigabyte as a unit, whatever value we get, or gigabyte with the same ink, and we'll have byte in here. In that case, we're gonna come up with the same units, GB or byte. Now I need to summarize both of the working to you, and for that I'm going to use a different ink. On the left hand side we have the memory size of 32 GB, and as the side was done for the image from bytes to be converted to GB, so we have the image size to be of whatever it is in GB as done in here. Fine. And on the right hand side we have again the memory size in bytes. How many bytes? These many bytes. And the image size as also the bytes, which was 369,3600 bytes. Fine. This is that image size. This is from where I copied. In both of these cases, we have a general rule of thumb, which is we need to do memory or total memory, we can say, being divided by the single image size. Okay, so the left hand side will take the form. On the left hand side, we have the memory or both the units in GB, and we were luckily on this side has the memory in 32 GB divided by whole of this thing as 369,3600 subdivided by 1024 cube. Obviously you will have or you would have solved it on the calculator, as this question is from the book and it is rather much more complicated than what comes in the exam. So you could have solved it as a single value. Whatever that value, you just need to do the simple division, and the right hand side will take its form because this side is in the form of bytes. So again, image size in bytes, which is this will come on top as 32 into 1024 cube divided by size of the image in byte, which is 369,3600. Again, you're gonna solve this and you're gonna come up with two answers, one in here and one in here. Fine.